Thank you for being here. It's wonderful to be here. First time I was in Russia was in 1991. This was when I took the train from China, from Peking to back home in the Netherlands. And it was a very different country then, of course. Russia was a very different country then. And you've made a lot of progress, an amazing transition. And I think also the world of energy is changing rapidly. And this is the topic of today, is the global energy transition. And what are the impacts of the gas sector of this energy transition? As Tatjana said, I've been in the energy landscape for all my working life. I started after university with Shell. Within Shell, I visited a number of countries in the Philippines, in Scotland, Aberdeen, in England, then I moved to the Netherlands. Between 2001 and 2005, I was part of Shell Renewables and Hydrogen. And Shell invested $1 billion in renewable energy technologies. I was also, when I left Shell about 6 years ago, I was responsible for the renewable energy activities of the Energy Research Center of the Netherlands. So this is a group of about 450 people doing research and development in wind energy, solar energy, bioenergy, energy efficiency, and also policy. So I hope to share my experience with you, but also I'm very much looking forward to this being an interactive session. So if you have any questions, please raise your hand or raise your voice or jump in and see whether we can make this interactive. So first, I'm going to talk about the major global trends that we see in the energy sector. Then I'm going to talk about the vision of the future of the gas sector in what I call a hybrid world. And then I'm going to ask a question, the gas sector, does it have a healthy future? And I would like to start off with one of the key themes of our time, and that is that global climate change is a phenomenon that we are familiar with, which is impacting the energy sector in a big time. And here you see some of the underlying reasons. Of course, the greenhouse effect is well understood. We know that if the greenhouse effect was not there, the temperature on the Earth would be similar to what it is on the Moon, minus 15 degrees centigrade. We would not be able to live on this planet. The fact that we do have greenhouse gases like CO2, like methane, like water vapor also, means that the average temperature is about 15 degrees centigrade. We know also that the amount of CO2 that we have in the atmosphere is increasing. And it has hit over 400 parts per million of CO2. And we also know that this is far above what we have seen in the last 400,000 years. Then, of course, the presumption is that if you know that CO2 is a greenhouse gas, and we know that the CO2 concentration in the atmosphere is increasing, what will that do to the temperature? And of course, this is where some of the difficulty is coming in. Because measuring global average temperatures is actually not easy. It sounds easy, but it's not easy. Here is the consensus of what we have seen in terms of temperature increase from 1860, when this was started, to where it is today. And what you can see on this picture is also two red circles. There's the 2 degrees centigrade limit and the 1.5 degrees centigrade limit. And these refer to the agreement that we have actually agreed globally in Paris. Is that the Paris Agreement has as the ambition to keep the temperature increase to within 2 degrees centigrade and to aim for a 1.5 degrees increase in warming. And as you can see from this diagram, we are getting already close to this 1.5 degrees centigrade of warming, and we will need everything within our abilities to keep it at 2 degrees warming. The Paris Agreement in 2015, of course, is the newest result of an international negotiation which has taken place decades. The first global agreement on climate change is the United Nations Framework Convention on Climate Change, which was agreed in 1992 between the parties. So that is already a long time ago. In 1997, we agreed the Kyoto Protocol. And in the Kyoto Protocol, we had the differentiation between countries who took on a commitment, the so-called Annex I countries, including Russia. Russia has taken already a commitment and its responsibilities in 1997 as part of the Kyoto Protocol, and the non-Annex I countries. And now the big achievement, of course, for the first time in Paris in 2015, we have a global agreement. And that means that not just the Annex I countries, all 200 countries or so, 196 to be precise, have a commitment under the Paris Agreement. Except, of course, that since that time, we have a new inhabitant of the White House, Mr. Donald Trump, who has actually said already in his election that he is not going to, that he doesn't believe that Paris Agreement is a fair deal for the United States of America, and he is not going to take action. So let me ask you the question, and maybe a show of hands. And I offer you two choices. One choice is, this means the end of the Paris Agreement, because US is a major emitter of greenhouse gases, it's actually the largest emitter of greenhouse gases, together with China. And this means the end of the Paris Agreement. That's option one. Option two is the energy transition and the global agreement to reduce greenhouse gas emissions is also going to go ahead without Mr. Trump endorsing it. Who votes for option A? Who votes for option B? Who doesn't know? It must be the rest. You overwhelmingly say that, you know, it is going to go ahead nevertheless. Can you elaborate what is shaping your thinking? Anyone?
This is a great chance for China to lead this process,
Mm-hmm.
which is technological, in my view.
Others will take the place of, China will be a leading entity. China was that was one of the reasons why Paris became a success. So that very early on, Paris and the US, they struck a deal, and they said, we're both going to make it happen. And there was real leadership at the point of US and Russia to make it happen. Okay, any other views?
We need to realize that the United States of America is not ruled only by the policy of Trump, of the president, but it consists of lots of states.
Yeah.
And they have their own policies.
Yeah.
So that's why Paris Agreement will be go on.
Yeah. Okay. Good. Fair point. Okay. We'll see. I think this is a picture about what actually needs to happen in order to reach those targets. And this is, there's many sources, but I've decided to take a source from Shell. And Shell is actually saying that in order to, let's sort of explain it a little bit. This is the sort of business as usual scenario, an unconstrained scenario. So we'll just keep on doing what we've always done, and then you get what you always got, and that is increased emissions of CO2 equivalents over time. Then Shell has put two rather aggressive scenarios, which actually they describe a world where greenhouse gas emissions will tend to be close to zero in the year 2100, and they're called oceans. One of the scenarios is called oceans, and the other one mountains. And what you're seeing here, that this is not enough. If you want to reach the 2 degrees centigrade target, you need to stabilize the global greenhouse gas emissions for a period until 2035, and then aim for a rapid reduction where you'll be below 10 gigatons of CO2 equivalent by the end of this century. And if you want to achieve the 1.5 degrees centigrade target, I showed you that we're almost there at 1.5 degrees. you need to aim for carbon neutrality by about 2050. And thereafter, go for negative CO2 emissions. So I'm like, whoa, this is massive. You know, 2 degrees centigrade target is already going to be very, very difficult to meet. 1.5 degrees centigrade, I would put personally, I would put it in the category impossible. So one of the key drivers to the energy system is the global climate change agreement. The other part, which was actually mentioned before, is technology development. Here I've shown the price experience curves of 2 of the most important renewable energy technologies. On the left you see wind energy, and on the right you see solar energy, solar photovoltaics. And what you're seeing is that, and these price experience curves, they're always on a log-log scale. So that means that for every doubling of installed capacity, the prices come down by a rather fixed amount. It's not completely linear, but you can see that with some ups and downs, the price development is rather consistent over time. So for every doubling of installed capacity, the cost of wind come down by 19%. For solar photovoltaics, the learning rate has been between 24 and 28%. That means that for every doubling of installed capacity, it comes down by 24 to 28%. And within technologies like wind and solar, they grow at 20 to 30% per annum. So this reduction of 20 to 25% happens every 3 years. And that is the cost. It's a technology. It's a technology that comes down every time. And what has that resulted in? It has resulted in the cost of offshore wind, which you see here, the cost of solar photovoltaics, and also the cost of onshore wind, converging around about the, let's say, $3 to $4 cents per kilowatt hour, 30 to 40 euros or dollar per megawatt hour, which is competitive to many of the fossil fuel technologies. You'll find it very difficult to build new build gas-fired generation at 3 cents per kilowatt hour. You may actually struggle, depending on the prices, with existing facilities to reach that sort of price level. So the point is that it's not just the global agreements on climate change, it's also the significant technological development that we've seen, in particular in wind and solar, that is shaping the future energy system. The other trend that we're seeing is that the energy system is changing from a rather central energy system where central power stations like coal, like gas-fired power stations, large gas-fired power stations, like nuclear facilities, like large hydro dams are, let's say, not just making place for, but at least being complemented by these more distributed energy technologies like wind and solar and storage technologies, where the generation is taking place a lot closer to the end consumer. And the energy system of the future, we believe, is a combination of still central sources, but complemented by more local sources. Sometimes people believe that renewable energy is by definition decentral. That is not the case. If you look at offshore wind, for example, in the North Sea, in the South Chinese Sea, near Taiwan, it is very central technology as well. We're talking about wind farms of multiple gigawatts, even larger than gas-fired generation, which needs to be evacuated. So The future is going to be hybrid. The future is going to be a mix of decentralized sources and centralized sources. Interim conclusion. Responding to climate change is going to be needed, is taking place at a global level, except a question mark around the US. Technology development is accelerating. The cost reduction is taking place, and competitiveness of renewable energy technologies with more central sources is nearing, and we're moving from a centralized to a hybrid system. Now, what does the future hold? And there are many scenarios going forward. I've decided to take an example from the Global Energy Assessment. Global Energy Assessment is done once every 10 years. The previous one was called the World Energy Assessment. Don't know what the next one is going to be called. But you see that over time, with the increased availability of end-use services like cars, like aeroplanes, like televisions, like all sorts of things that we as humans want, the energy system has grown to something around 600 exajoules now. But what we've always seen, is that the new energy incumbents that have been generated over the past century have not actually resulted in older technologies moving away. What I find fascinating is that, of course, we have biomass, but here we have coal, we have oil, and we have natural gas, we have hydropower, and we have renewables. And the new renewables are hardly visible in this chart. But all of them have continued to grow in the previous century. And I think for the first time, we're moving towards an energy system where not all the primary energy sources continue to grow, but where we have to make choices. And the choices are mainly also between which of the fossil fuels are we going to leave in the ground. And what you see in this scenario, so you see multiple scenarios going out to 2030 and them being extrapolated into 2050. You see, first of all, continued growth of energy demand. There are actually some scenarios which anticipate actually a declining energy demand. But here we see significant growth, which is mainly driven by increased population growth. So we're moving towards between 9 and $10 billion people in 2050. And it's also driven by increased energy services per capita. So the developing countries becoming richer. How are we going to meet that demand? In most scenarios, even the scenarios from BP, ExxonMobil, Shell, you see an acceleration of the growth in renewable energies. Renewable energy technologies are going to take a big chunk of the new supply. And here you see, for example, solar, you see wind, you see hydro. Some scenarios anticipate sort of a nuclear comeback. And when you see fossil fuels, as in this case, in these scenarios, you see a lot of carbon capture and sequestration being included with it in order to reduce the CO2 impact of your fossil fuel production. We don't know. Nobody knows what the future of energy is going to be. But as I alluded to, we may be entering a period where not all the technologies can continue to grow forever. At least otherwise we're not going to meet our climate change goals. This is the summary of the Global Energy Assessment. Energy systems can be transformed to support a sustainable future. I'm not going to read it all out to you. I'm going to give this with you. If you're interested in reading a scenario, I do think that the Global Energy Assessment is really one to include. Then moving on to the shell scenarios. Earlier I mentioned the oceans scenarios and the mountain scenarios. They anticipate a world where there is going to be action on climate change. And they're going to, they've also included a scenario which is called the oceans clean and green. So this is a much more aggressive scenario again, compared to the ocean scenario. And what I said before is that these scenarios are not actually going to be sufficient in order to meet the 2 degrees target. So something else needs to happen on top of it. And I think this is the sweet spot where we are finding ourselves now, is that we don't know what's going to happen. The future is uncertain. It's going to be a combination of forces that is going to drive the future energy system. And the future is going to be messy. And there's some people who say gas is good, because gas, out of all the energy sources that we have, coal, gas, oil, is the least CO2 intensive. There will be groups who say, but gas is also a fossil fuel, and therefore there will be opposition. So to what extent the future is going to be gas-based, or to what extent it will be renewables-based, is still very much uncertain. And moving to the third part is that implications for the gas sector. Here I've actually included a slide from Gasunie. Gasunie is actually here. And Gasunie is one of the leading transporters of gas in northwestern Europe, with the network in the Netherlands, but also a network in Germany. And they have looked at their strategy and they're saying, we see a role for our pipeline system in the near future, because gas is clean and gas has got a major role to play in greening the current system and meeting the targets that we have now. There will be a cleaner form, and there will be the cleanest form. And so Gasunie is thinking about its role in society, is looking at renewable gases, gases that are produced by bioenergy, biogas, for example, gas-produced hydrogen, for example, that is produced from electrolysis of wind and solar, and then thinking about what is the future of the energy system and what is my role going to be in this energy system. What is the role of Russia? This picture I've taken from the Shell scenarios which were developed in 2000, and it's looking at the renewable energy resources that are available per capita. And it's first of all looked at what is the demand range, and that we'll see for people living in 2050. And the assumption here is that everybody would be living sort of according to Northwest European living standards, which means that the demand range is about 100 to 200 gigajoules per capita. It's then looked at what is the available biomass resource that is available per capita. What is the geothermal resource that is available per capita? Solar, wind, and hydro. And what you see is that those countries which have a lot of, let's say, space, and in this case, the former Soviet Union, which it was still called at the time, has got a lot of space. The population density is very low. They have a very rich renewable resource base. The opposite is also true. Europe is very densely populated part of the world. The amount of resources that we have available per capita is correspondingly a lot lower. Russia is a major partner towards northwestern Europe in terms of gas supply. And what I believe is feasible and should be considered is, can Russia actually also play a dominant role in becoming a major supplier of renewable energy to the Northwest European market or the European market. I think that in terms of cooperation, there is a need to work together. There's a need to work together in terms of gas supplies and developing gas supplies in Europe as a transition fuel. But there is also going to be a potential to work together on monetizing this vast renewable resource base that Russia has got available. And this is where I wanted to leave my story, is that first of all, what I've tried to outline to you is that global climate change is going to be a major issue with a global agreement in place, adhered to, maybe not by the US, but by 195 governments are pushing for this implementation of this global agreement. That technology development is going very fast, and that renewable energy technologies are reaching competitiveness with conventional fuels. The third, we're moving towards a hybrid energy system where renewable resources and more central resources are working together to shape the energy system of the future. That there are multiple scenarios, and that those scenarios anticipate, first of all, a growing amount of energy consumption driven by population growth and driven by developing countries becoming more affluent. That the energy mix of the future is going to be more diverse, where in the past, let's say, all of the energy technologies grew, driven by this increased demand, where we will be moving to a future where not all fossil fuels can be produced to the maximum, driven by climate change constraint, and that technologies like carbon capture and sequestration may be a useful complement to some of the fossil fuels. And finally, that the cooperation that has existed between Russia and Europe in the space of gas is something that I believe should be further developed, and into the future we should be looking at how we can together develop this large renewable energy resource base that Russia has got to its disposal. Thank you very much.
Thank you. Hi, Robert. My name is Valerie. So I have a little bit down to yours question about business strategy of oil and gas incumbents deciding to penetrate the market of renewables. So we understand that there are several options to do that, several routes. So basically, the ultimate goal of any of them is to gain expertise, to choose the least risk and shocks-prone way, and to pursue the most gradual transition. But there are basically three options, maybe more. So organic, kind of gradual divestment of gas and oil, hydrocarbons assets you have, and buying maybe, I don't know, changing them to renewables. Another option would be to pursue aggressive acquisitions like Total do with their solar power, etc., etc. And third option would be to divide yourself into two parts, like you own a Uniper, and basically pursue different ways of development. So what, in your opinion, would be the most efficient way for expertise, for not losing profits? Yes, because you still need to show your shareholders some value. Yes, and at the same time, gaining expertise and penetrating this market. So what is your opinion?
It's a very good question, a very difficult question. I think one of the things that you need to do is to look at what are your own core competences. And like when I was with Shell, we invested in solar PV panel manufacturing. And we found that it was very different from the core business of doing Shell. We also looked at offshore wind, which is a technology where you throw, nowadays for a 750 megawatt wind farm, you invest about 2 billion. So those are the sort of things that a Shell company and also Gazprom and Rosneft are familiar with. So I would say that if it's very close to your core business and you have something to add already into this space, I would go for an organic growth strategy. And that's what you see Shell doing also, is that they did actually make a bid together with Van Noord and Mitsubishi into the Northwest European wind markets to develop projects. And like it develops projects in the oil and gas space. I think if you are wanting to invest in a technology which is very far removed from your core business, I would go for an acquisitive strategy. Maybe an example is Engie or Total. Engie decided to buy Sungevity out of Chapter 11, at least the European assets. And it's leaving them alone. It's sort of saying, well, this is not something that we're very good at sort of solar panel distribution and selling. So if we were to do it organically, it would never work. So we're going to buy a company, we're going to set it apart so that we are not going to load all these corporate bureaucracy on top of this small company, otherwise it would die. And it would try to nurture this small company into something big. So I think it depends a little bit. I think the most important reflection that the industry will need to do is where are my core capabilities? Where do I think I can be successful in? Which technologies? And then, depending on the answer to that question, is decide whether to go for organic growth or whether to go for acquisition.
So you see that the relations of Russia with Europe are not that very easy nowadays. So if this plan does not work, what other strategic partners we can have in renewables? Is it Asia or something else?
I think the cooperation with Asia and with China is going to be very interesting, I think, for Russia. I think it's a natural partner, also geographically. I think Asia is a major powerhouse when it comes to the renewable energy sector. About 80 to 90% of all the solar panels are being produced in China. In let's say, until 2010, China was the major manufacturer globally without installing much, but in the last 7 years or so, China has also become the major deployer of renewable energy technologies. So I would say that China as a partner for Russia is as interesting as Europe as a partner for Russia. And if I were you, I'd just try to develop relationship in both directions.
Thank you very much for your presentation. It was very interesting. My name is Anastasia, and I'm studying at Moscow State University, Institute of African and Asian Studies. My thesis is about the development of alternative energy in China. And my question is hydropower, can hydropower be considered as a renewable energy, or only small hydropower stations is really a renewable energy source?
This is a definition issue. I think if you look at hydro, then large hydro definitely, also in my book, is also a renewable energy resource. Although it is sometimes excluded from the official statistics, and the reason why that is the case is that hydro has got one drawback. Is that in order to create a hydro dam, you need to displace some land, and there's a lot of vegetation which is composting and creating methane emissions. So therefore, some environmental groups, or many environmental groups, they don't really like large-scale hydro. I think if you look at the pure definition of renewable energy resources, so resources that are not depleting, then there's no question, and it should be counting as renewable energy technology. I think, to be honest, that you do need, when you have large hydro dams, you do need to take into account, like any big project, the environmental effects. But I think that we do need hydros of all sorts, small, medium, high, in order to meet the objectives. But then it needs to be done in a responsible way, and cannot be done everywhere.
Yeah, Christine Wilinski from Mingas. I have a question with respect to the slide. Okay. I would like to understand how like these renewable energies can be exported. Because I understand it like there's this large amount of solar, and I understand that you can only export solar when you make electricity, and then you have to build infrastructure to export electricity.
Yeah.
And the second question is, where does come this potential from? Is it that Russia is a big country and there's so much space, and where comes this hydro potential from?
Yeah, the last one is indeed correct, because it's got so much space, it's got a lot of elevation, so that is the reason. How do you transport all these renewables? I think at the moment there's 3 ways to transport energy, and there'll be a 4th one shortly. And the 3 ones are heat, there's electricity, and there's power, at least for electricity. Of course, there is also coal shipments and that sort of, so you can actually transport oil and gas and LNG also as a primary source. But as towards the end consumers, these are the ones. In the future, hydrogen will be a possibility to ship it. I think if you look at renewable energy technologies, then biomass is pretty versatile. Biomass you can actually ship as a diesel, you can ship as petrol. You can produce heat out of it, then it becomes less transportable. You can sell electricity, you can make it into electricity, you can make it into gas. So out of all the renewable energy technologies, biomass is the most flexible in terms of transportation. You can see a future where the gas network that is extensive in Russia and goes all the way west and east is being used in order to transport biogas. That is a possible scenario. How realistic? I don't know. If you look at wind and solar, they predominantly produce electricity. Of course, electricity is so it's background to your question. It's the most difficult to transport. It's about 10 times easier to transport gas than it is to transport power. Of course, there is innovations in terms of power transport, in terms of direct current transport, where the losses are less over long distances. You would use DC in order to transport it rather than AC, but also there the losses are quite significant. And therefore, I think that if you really want to move into a world where you can produce through solar photovoltaics or concentrated solar power, electricity for, let's say, 1 cent per kilowatt hour, then you can actually convert it into, for example, a liquid carrier. Hydrogen could be a contender. Could also be ammonia. If you attach the hydrogen to nitrogen, you get ammonia. And then use mass transport of this liquid all over the world, or indeed hydrogen, which you need to invest some energy in order to make it liquid. You can also ship it to the major consumption areas. So I think at the moment, it is far into the future, right? Because we're not into this situation that we have, these large areas with a lot of space and a lot of rich renewable resources, like in the desert environment. But it is possible if you convert it into something that is more transportable to transport it over long distances. I don't know whether you're familiar with the Desert Tech project.
Does this project really shows there was also a lot of potential for this project, because it was said, okay, there's a lot of sun, we can produce electricity there, and then we can sell it to Europe. And what I think the project ended up.
Yeah, maybe it was a little bit too early, but this was in in Morocco and in North Africa. Of course, there's a lot of space, there's a lot of sunshine. So the idea was, let's put our PV panels there.
I'm Volker de Jong from the Energy Delta Institute. already this afternoon. I listened, of course, to your very nice story about the energy transition. I have one question. You started with this Mr. Trump being there, and my question is, if you look at the energy business, in the end, of course, there are many stakeholders that give you the license to operate. It's the customers, it's the politicians, it's the investors, etc. So especially in the Western world, where you can see a very unstable political climate, how much will that impact? How much will you be able to really get close to this gas renewable energy system moving ahead? Or will some of the stakeholders, just like Mr. Trump, that start blocking it because they simply see their own interest too much threatened in this?
Yeah. It's a good question. I think, you know, I want to go back to this slide, this shell put up like the transition is messy. Like there's all sorts of vested interests sort of jockeying for position and lobbying. And the ones that you mentioned are amongst them, but also, of course, in this whole global climate circus, because it is a circuit I've sat through COP5 and COP6 in 2000 and 2001. And it's a big gathering, and if you just imagine yourself in Saudi Arabia, you know, being the largest producer of oil, and you're thinking, wow, you know, we're signing up to this global agreement to limit the very use of my product. You know, imagine what sort of lobbying goes on. To be honest, I don't think how everything will unfold. I think the fact that we have, for the first time, a global agreement is nice, but completely insufficient, as I've shown, to what is going to be needed. One of the elements of the Paris Agreement is the so-called ratchet mechanism. So that means that every 5 years there's a mechanism in place where countries are going to review their contribution and are going to sharpen it. But how is it going to work, and what's going to happen if somebody says, you know, I'm just going to leave it at the level that I had initially agreed? Is someone going to send in the troops? It's not unlikely, right? So we don't know. To be honest, I think the only, if I'm thinking of this carbon constrained world, I think the most certain way to get there is if the cost of renewable energy technologies will get so cheap that it's outcompeting fossil fuels, and then I think a lot of the debate will be over, because then you're not, you know, no longer asking people to subsidize renewables, or if it's a choice between should I be building hospitals, should I invest in education, or should I invest it in renewable energy deployment. It's always difficult discussions. But if you can somehow foresee a scenario where these technologies are so cheap that they're better than conventional fuels, then I can see it happening. Only in that case.
Viktor Naboychenko, NL, Russia. Question in furtherance of your previous statement, actually, grid parity, technological development. Based on your gut feeling, well, when will it happen? I mean, the situation when it will be economically reasonable and economically justifiable to proceed with renewables for country, for specific company, and as a subdivision of this question, role of industrial accumulators. To what extent they will impact development, and do you see any technologically sensible projects, some disruptive technologies that would change this picture and accelerate a little bit this progress? Thank you.
Maybe first say something about the concept of grid parity. So grid parity is often seen as the holy grail of renewable energy cost competitiveness, right? And I think it's worthwhile looking at, well, what does it mean, grid parity? I think the competitors of renewable energy technologies depends a lot on the application. So first I would say that the earliest, most competitive application for solar PV we had was in space. because there is no competition. So PV was already competitive in 1985 in space applications. It then became competitive in remote applications. So, for example, diesel fire generation, which was producing at cost of, let's say, $40 cents per kilowatt hour or $30 cents per kilowatt hour. That was the next competitive market. Telecommunication mast in the 1990s, where PV was already competitive. So then you move into an area where you can compete with consumer electricity prices. So I'm paying 21 euro cents per kilowatt hour for my power. So if I put a PV panel on my roof, I don't have to pay this 21 cents per kilowatt hour. Now this 21 cents per kilowatt hour is a combination of the price for generating it, which is about 3, 4, 5 cents per kilowatt hour. There's all sorts of taxes on it. There is distribution, transmission charges, blah, blah, blah. So then that was the next big market in which we're competitive. And now grid parity is that you're actually able to compete at the wholesale electricity market. So at this 3 to 5 euro cents per kilowatt hour. Offshore wind is now at 6 euro cents per kilowatt hour. Onshore in Northwestern Europe, onshore wind is about 4 or 5 euro cents per kilowatt hour. So you can already see that in certain markets, grid parity has been achieved. It depends a lot on the quality of your resource. Like in the world record for PV prices is in the United Arab Emirates, and it's $2.50 cents per kilowatt hour. It has achieved more than grid parity. It is the most competitive form of electricity around. And now you get the next big hurdle, and that is because people are saying, wait a minute, but you're not competing on a like-for-like basis, because my diesel-fired diesel genset on this particular island or on Hawaii, for example, is producing firm power, and your PV installation is got this peak during the day. So the next hurdle is for grid parity and storage, so grid and storage, to achieve parity. So if solar plus battery storage or some other form of storage can be cheaper than dispatchable competitors, then you're really in a new space. Then you're really sort of cracked it. Yeah. So my story is, when people say, is it competitive or not? It says, well, it was already competitive in certain applications. So there have been more and more applications into the consumer market, now into the wholesale market, and ultimately renewables plus storage. If it can outcompete fossil fuels, then you've really nailed it.
Now comes the question when.
It really depends on the quality of your renewable resource. Like it's a question like, what is the price of a barrel of oil? What's the price of a standard cubic meter of gas? There is no one price. In Saudi Arabia, you're producing a barrel of oil at $2 a barrel, a real production cost. You know, in the North Sea, it may be 50. So even for fossil fuels, there is no one price, and the same is true for renewable resources. Like in the Netherlands, we have a very flat sea, and it's flat. All the seas are flat, but I mean shallow, 30 to 40 meters of water depth. Where we've got companies like Van Oort, and they're very good at installing it. I've been on a mission to Japan and Korea. In Japan, the sea conditions are very different. This is a volcanic island, so the water depth is dropping off very quickly. So even for offshore wind, you know, you need to go for floating applications, completely different technology. So I can sort of say, well, offshore wind is 6 cents per kilowatt hour, but it's 6 cents per kilowatt hour, 20 kilometers outside the Dutch coast. 20 kilometers outside the Japanese coast is a different ballgame. And I think a country would be wise to look at not just where are my fossil fuel resources, because we've got that pretty much well mapped, But also, where are my renewable energy resources? Well, do I have a lot of biomass? Do I have a lot of wind? Do I have a lot of solar? If so, where are the likely developments coming first?
I've still one issue, of course, being an econometrician and background. I always have difficulties with the calculations that are used. You feel that almost like a salesman, we try to put, for example, take this parity issue there, but then you forget to say to society, we have an existing infrastructure with an economic lifetime of 20 years. If in 10 years the gas infrastructure will be worthless, who is paying for that? So that a lot of these costs are much more tricky than just going to parity level, because you have to replace an existing system. Just like if you have a house and you have to go to somewhere else, there are a lot of costs involved with moving from one place to another. So if you cannot sell your house, you're in big trouble. And that's the case here as well. And these costs are never told to the taxpayer, and suddenly they pop up. Even in discussions, I sometimes say, if you pay for these costs, I'm willing to invest. If you're not paying, I know as a taxpayer, I will pay for it in the future.
Fair point. Yeah, no, and I think that's also why, from a societal point of view, it's good to have a long-term strategic plan. Yeah. What am I going to do with my energy system? Because, like in the Netherlands, we built 3 new coal-fired power stations, and one of them was commissioned last year, and now people are saying, well, who on earth decided to build these coal-fired power stations? Nobody needs them anymore. And it is the tremendous cost to society to I don't know, 15 years after the United Nations Framework Convention on Climate Change, to be deciding I'm going to put a coal-fired power station in it's. But then again, you should say that those people who made the investment, they should perhaps also be penalized for it. It's private investment, so the people that made those decisions, yeah, they took the risks, so they should also take the consequences. That would be my view.
Because you get, from an investor's point of view, that the government is changing regulations and changing all the time commitments, which does make you as an investor tremendously nervous.
Yeah, business needs a stable framework, that's right.
Can you please elaborate a little bit on the gas cogeneration? Because, so, I mean, what are the success factors on which success hinge in those projects? What are the capabilities gas company can use to which capabilities gas company can harness to achieve this mystical synergy, and apart from cheap feedstock, what are the areas, what are the countries which hold the most potential? Maybe some figures, maybe some costs, something.
I think the gas companies, and let's say it depends. Are you a transportation company like Gasunie, the example that I gave? Its core business is transportation. So you sort of say my capability is not just in transporting methane, but transporting renewable gases, etc. If you're a gas exploration company, I would say you're very good at large project development. Like you've got a capability to develop large projects and to bring these to final investment decision, to talk to various stakeholders, etc. I think government relations is always a strong point of gas companies. Wherever you work, you always have to work with all stakeholders and also within the government. So those are a couple of strengths that gas companies have and can leverage also into the renewable space.
Thank you very much for your lecture. And what do you expect to be the most widespread way to buy gas? Whether it in the future, whether it would be, it will be spot or long-term contracts? Thank you.
Yeah, that's also a question that came up earlier. My personal view is that in the, let's say, in the electricity markets where a lot of gas is being used, the demand and supply is going to be more than in the past determined by the variability of renewable energy. So what you're seeing is that the spark spread will flip. So we'll see periods of a lot of supply of renewable energy. Renewable energy produces at zero or very low marginal cost. You see very low electricity prices. So you see gas-fired generation not being able to make any money. It will be idle because it will not be needed. Then there will be periods where there is not a lot of renewable energy supply, where gas will come into the merit order and will compete with coal and other dispatchable sources in order to generate the power that is going to be needed when renewables will not be there. So I think first of all, the pricing of electricity is going to be market driven. Like every hour, it is different in power markets. So this fluctuation will find its way also to the gas market. I personally believe that, of course, we've seen in the last years an emergence of spot trading on the TTF, on the NBP, in particular in Western Europe. I think in Asia, of course, it's a different situation again. But if you talk about Northwest European markets, we have seen a tendency to move to spot market. And I think given this whole supply-demand situation is going to continue. Will there still be a role for fuel oil, gas oil pricing into the future? The conclusion was that until 2030, where there's still a lot of fuel oil, gas oil pricing in the market, contracts in the market, that will continue to have an influence on the way prices are set. Thereafter, I think it's quite uncertain.
Mr. Kляйбурга, thank you for your report and your answers. They are really very interesting. My question is very small. We are talking about the renewable resources. We are talking about the gas, oil, and some others. What do you think about the nuclear power?
The previous organization I worked with, ECN, had two parts, a renewable energy part, where I was responsible for, and a nuclear part. It was producing medical isotopes. So I was somewhat constrained with what I said about nuclear. But now that I've left this organization, I can be open about what my views on nuclear. And I think nuclear Hinkley Point is, let's start from the premise that hardly any nuclear reactors are being built in Europe anymore. There's only one that is now received final investment decision, and that's Hinkley Point. And it's received a contract for difference for 50 years, which is far higher in terms of that's 13.5 cents per kilowatt hour, far higher than the cost of renewables. I think it's a white elephant. I personally don't think it even will get built. I think there will be so much political opposition that they will come back from the decision to build the Hinkley Point. And I don't see a lot of nuclear reactors being built because simply the cost is far too high. Renewable energy technologies have progressed so much that it is easily outcompeted nuclear technologies. Then, of course, that is for the current generation of nuclear technologies. Then the question is, well, what happens to nuclear energy technologies? And will we see new reactor types, maybe inherently safe reactor types, which are out there maybe 10, 20 years from now, which are coming into the horizon? I'm personally doubtful that the next generation of technology will be far cheaper, so I don't put high hopes on it. Then we have nuclear fusion. Nuclear fusion, the joke is always nuclear fusion is 50 years away. Like 50 years ago, it was 50 years away, and here we are. And nuclear fusion is still 50 years away. And it's, of course, it's being tried in Cadarache in the south of France. They're building this prototype nuclear fusion reactor, but it is so difficult. It is so difficult to contain this giant energy source into the technology that we have. You can't use any metal. You need to contain it in a magnetic field. It's so complex that I don't think this will ever be a cost-effective technology. So it's a personal view. You're asking from a personal view. I don't believe in nuclear energy development going into the future. What I do actually believe is that the current nuclear reactors that we have is that we accept if they're on an earthquake-prone area, like some of the nuclear reactors in Japan, we should try to extend them for as much as possible. Because I think that if you have a CO2 emission-free energy source, which nuclear is, and you've already done the damage in terms of the site and all the nuclear waste that's being produced, let's sort of run it for the end of its lifetime and then see whether we can actually do something with containing all the waste that is on that particular site.
Thank you. As we move along with all of these various energy types on a kind of energy safari, could you also comment on the CHP, combined heat and power, current and future role in Europe?
I'm one of the key benefits of gas is that the opportunity to do CHP. And I think in the Netherlands, for example, we have 3 gigawatts of CHP with growers. The Netherlands is the second largest exporter of agricultural products, and many of these growers, they produce power and the waste heat they use in their processes in order to heat the glass houses. And it's a very effective way of using gas, because you use all the benefits of gas that you have. And in this more hybrid energy system that I showed, I think there's definitely a role for, let's say, the distributed use of gas, using it for power generation and using the heat as well as the power in order to very efficiently fuel your economy. So I'm a big believer in it, and I think I think one of the things that I'm most annoyed about is that in northwestern Europe, the way the spark spread has acted, it was a lot of gas-fired generation, including CHP, was mothballed, and big coal-fired power stations were running. I think that's a disgrace. But
thank you. And just a continuation, do you see similar trends in terms of pricing on technology that you showed for solar and wind? Probably not to the same extent, but also on the micro CHP technologies like micro turbines and things like that.
Yeah, I think even to the extent that in the households you can actually combine production of heat and power. That is being tested also in the Netherlands. I think that's got a potential role as well. I think generally in the more incumbent technologies like the fossil technologies, the progress is less fast because it's in a different part of the learning curve, but you definitely do see technology development there. Yeah.
Probably the most intriguing question is, at least for me, on the potential relationship that, I mean, we are doing different assessments of gas and renewables and system effects and electricity storage and the way how the new energy system could look like with the larger implementation of distributed energy, not only generation but also storage.
Yeah.
Yeah. And so it seems that a sort of revolution is approaching on the way how the whole energy system is organized with the growing role of these smaller decentralized sources and decreasing role of the centralized large-scale generators. So looking at this movement, how would you see the successful company strategy? And especially I'm thinking first of all about Russian energy companies, which, you know, Russia is very much dependent on hydrocarbon exports, not on renewable exports. But anyway, for us that's a critical question, how to keep in line with this revolution, not to be left behind like previous century. So do you have any idea, any recommendation, what some obvious steps which we should have done like 5 years ago, but still there is a window of opportunity which we should use? So any recommendation from your side?
Yesterday I had dinner with a friend of mine, and he's been in Russia for the last 20 years and with his business, and it's a bit like the answer that I gave to you with China. He said, the Russians, you know, when they will put their mind to it, they're also going to go for it. And I think, I think maybe we have not reached that step yet, but I really hope that you're going to make a strategic choice to become big, not just in gas, but also in renewable energy technologies. That is step number one. Then step number two, I would say, look at your renewable resource base. Look at where you have your strengths. Look at your capabilities, and really make a couple of bets. Like when I was with Shell between 2001 and 2005, responsible for strategy and planning of the renewable energy divisions, we also said we're going to move into offshore wind. We're going to move into solar photovoltaics. We're going to move into biomass. We're going to move into.
By the way,
hydrogen.
sorry for interrupting, but it's extremely interesting. What was the reaction of the other divisions of the company? How did they react to these suggestions? Was there an opposition inside saying, "What, are you crazy going for these renewables?"
No, I don't think. I think many people that sort of Shell have been making these scenarios and saying that renewables will be big. So many people said, if we really believe it's going to be big, why don't we just also play in it? And if you like, there was a lot of people from other divisions that wanted to be part of it. So I would say, first of all, make a strategic choice to become big in renewables. Second, select a number of renewable energy technologies that you believe you can be good at, that build on your core strengths, and actually make it happen, and then just go for it. And I don't know, the earliest question we had is, should we maybe acquire a company, or should we organically grow, or these are all sort of, for me, they're all sort of implementation questions. But it starts with a realization that this is big. This is already a $300 billion business, where Russian companies have got a very small part of. Make the strategic choice. Look at what you're good at. Place your bets in those technologies where you really think you can make a difference, and then go after it.
Great, thank you so much. So I will ask everybody to join me in thanking Robert. And this is a small cup for you to remember about your visit to Skолkovо.